All right, so as far as the, or like I said, there's actually several lessons here to go through, so I'm going to try to go through while I'm video recording this here. So speeds and feeds. Okay, so this should all look familiar. It's very similar to what it was in the mill. It is a little bit tricky though, so let's go through it just real quick before we jump into the hands-on. So this is basically the same formula as you had before. I'm cutting speed. Okay, so that's how fast the tool is hitting the part, right? Or the parts, I'm sorry, the part's hitting the tool. Okay, it's how fast this thing's spinning. Okay, so it's the diameter, which is all the way around this thing, times the RPM, that's what S is, okay? It's the spindle speed. Okay, so it's how fast is it spinning times pi times d, which is the circumference. So if you think about it, it's how much it travels, which is all the way around, and how many RPM. So that's basically the feet per minute it's going to go. All right, because it's a full circle of it, the length of it, times the RPM, and that gives you the cutting speed. Okay, so the biggest trick with this one that catches a lot of people. Okay, so what they'll say on the homework questions are, you've got a 1-inch diameter and you're taking 1/8 of an inch off or something like that. Okay, so if you've got a 1-inch diameter, say this thing's 1-inch diameter, and you're taking 1/8 of an inch off, well, the tool's hitting 1/8 of an inch into the part, and that's on the radius. So it's taking 1/8 inch all the way around this thing off. So your D is 3/4 of an inch, 0.75. So if you start out with 1 inch, and it says it's taking off the tool's taking 1/8 off, that means it's taking 1/8 off the radius. Okay, that doesn't mean it's taking 1/8 off the 1 inch. Or if they say the depth of it's 1/8. You got to really read the fine print. Okay, so if the tool's going in 1/8 of an inch into here, there's a whole 1/8 all the way around. It's getting wiped out of it. All right, so you use 3/4 in that instance. So make sure that the biggest mistake students make is they use the wrong diameter. So make sure you use the diameter of where the tool's touching. Okay, not necessarily the diameter of the part. It's a pretty simple formula. Plug in D, plug in S. Multiply by pi divided by 12. Okay. This is the same formula, just reconstructed. So you solve for S. So basically, divide both sides by S. Divide both sides by diameter and pi and multiply by 12. And then you end up with this formula here, okay? And then this is the same thing. It's just basically 12 divided by pi is 3.82. Now your book shortcuts this and calls it 4 times V divided by D equals spindle speed. Well, it's not really that. So if you use the book's formula, you're not going to get the right answers on my homework because, that's almost, that's 5% off. So in my world, 5% is a lot. So it makes a big darn difference. So you definitely don't want to be 5% off the right thing. So don't use the book 4V divided by D. You need to be using 3.82 or 12 divided by pi to give you very similar. All right, so that gets you within 1/1000th of being right at least. All right. So either use this formula or use that one. Don't use the 4, and you'll get the right answer then. Feed rate. So feed rate is just how fast it's traveling along the part. Okay, and there's 2 ways to say that. You can say inches per minute, which is the one we usually use, and it's basically how much. It's the RPM times the inches per revolution. Okay, and then you can solve for the other one, inches per revolution, if they give you inches per minute and divide it by the RPM. Okay, so if they say I want to know how many inches per revolution the feed rate is. Okay, so this is a feed that basically is cutting into the part again. So if you do the feed, if they give you these 2, you can solve for the other one. Now, if they also give you the diameter, you don't need it for this. Okay, so if they're talking about feed rate, they'll use one of those 2 formulas to solve for the other. All right, so that should be all the problems you would have with it. Like I said, don't use 4, use 3.82. Make sure you use the diameter where the tool's actually touching. Appendix C of your book gives you a nice place to start out with knowing these. So whenever you're setting up like cutting aluminum or steel or plastic or whatever, you always need to know the speeds and the feed rate. Okay, And it depends on what kind of tool you're using, how strong the machine is, and that's what this all says basically, okay? How fast you're going, how deep you're going, how many horsepower the machine is, if your clamps can hold it so it doesn't become a projectile and end up in somebody's leg, you know, or something, which I have seen that happen. One of my friends at Stevens almost died from that. The board was not clamped down very well, and it hit him in his main vein in his leg, and he almost bled to death. So he still didn't walk right. So you want to make sure things are clamped down good. 7 horsepower or 30 horsepower, depending on the machine, is a lot of power. It can throw something out like a bullet. A lot of times you want to bolt it down if you can. So that depends. But if the machine will handle it, you know, you want to go as fast as you can too. So that's why they use all that power. But to figure out the speeds and the feeds, the Appendix C it gives you those numbers to start out with a lot of times. If you're ever out on your own, you've got a really good book there. If you start working for a machine shop, keep that book or buy one like it. Let's see here. So that's speeds and feeds, lesson 7. That should help you on your homework, hopefully. And there's also even more information in the book. All right, the next one, a little bit of lecture this morning, is, which I know a couple of you already got it done, which is great, but I'm going to go over it anyway just in case somebody gets confused. Okay, so I'll tell you a few shortcuts here on this one, all right? So you have to calculate these positions and then pick which ones they are, all right? This is a little tricky. It's not too bad. So the formulas you need to solve for this basically are, I don't know if I have you type it in anymore. I might have you pick the numbers. Julia, did you pick those numbers or did you type it in? Do you remember?
They're all in there.
Yeah, you just picked the right ones. That's what I thought. Okay, so you shouldn't have to type them in anymore, but you still do have to know which ones are right. So on a triangle, there's a couple of things. Everybody hopefully remembers the little thing, SOHCAHTOA or whatever, basically. SOHCAHTOA. So let's see if I can remember it. So sine is
opposite over adjacent.
Why do I have it like that?
Opposite over hypotenuse.
Yeah, this is ABC. So let's see here. Sine of angle A. So that's that one, okay? It's got ABC, but so we're trying to calculate the sine number of basically this angle A right here. So it would be the opposite over the hypothesis. So that's S for sine, O for opposite, H for hypothesis, okay? And then if you know those two, you know the sine, you can figure out the angle. If you know the angle, you can figure out what the sine number is for this, okay? And from that, you basically have to, if you know any two things here, A or C, you can figure out the angle. If you know the angle and you know C, you can figure out A, okay? So that's the sine equals that. So there's a little bit of geometry here, so you have to use that to solve for this. If you don't know A or C or the angle there, maybe you know B, you can calculate the answer of the other ones from cosine, because cosine equals adjacent over hypotenuse and tangent equals opposite over adjacent. Okay, and then the other ones you would use is A squared plus B squared equals C squared. So if you want to solve for like A squared here, you would take A squared equals C squared minus B squared and take the square root of that to solve for one of them, all right? And these formulas are in the book too, but it's kind of just a little bit of an answer on it. So when you have to, let's look at this one here. So this one here is basically saying what numbers to put in here, right? So to get you started, it says 1A, okay? So this is A, okay? And this is B, all right? So we're working up here. All right, so 1A, figure out what the X and the Z. Now X is up and down. Remember, it's goofy lathe talk. It's not. So it's basically what you're used to saying the Y is. So it wants to know what point 1 is. All right, so 1 would be 3.5 minus the distance from here to here, which is the radius, okay? So it's 3.125 would be X, sorry. So X, or Z, X, and I'm saying it backwards here. Z would be equal, this is horizontal, what you typically would be X. And it really confuses me because I've been doing it for 30 years. as far as drafting goes. So 3.5 minus 375, this is Z. So 3.125 goes in there. All right, that'd be the first one. And then the X is the up and down, and it's just the radius again. So it'd just be 3.375. And then you just keep on working down here. So number 2, the X is going to stay the same. It's straight long here, so it's 0.375 again. All right, and then the distance would be 3.5 minus 1, okay, be 2.5. All right, now this is where you start having to use a little bit of a trig here. So this is 40 degrees, right? So you draw a straight line across here, and it's 40 degrees between the two. All right, so then you have to use a little bit of math. You have to use you're trying to find, so if you imagine there's a little angle, triangle right here, you're trying to find this little distance and add it to 375, right? So you know that distance is 125 minus 1, so that's 0.25 long. Okay, if I know that, and I know my angle is 40 degrees, so I know the adjacent, and I'm trying to find the opposite. Okay, so I need opposite over adjacent on that one. So if I go back to here, opposite over adjacent would be opposite over adjacent sine A over B. So it would be tan. Okay, so you use tangent A equals A over B to find it. So you put tangent of 40 degrees equals A over 0.25, since it was 1 minus or 1.25 minus 1. Okay, so to solve for that would be tangent of 40 degrees equals A over 0.25. So you multiply 0.25 by both sides and you're left with A. You got to solve for A. Okay, and that gives you the height. Okay, that gives you this height. Now you got to add that to 375 to figure out what the X is in that instance. Okay, and then this one is basically the same again on the X because it's straight over, and then the Z would just be 3 minus 2.375. Okay. All right, and then this one's kind of the same thing, except you're solving 65 degrees, so you're trying to find this distance right here. But again, it is, and they're giving you 2.0. Okay, so you know this, half of this 1 minus this minus whatever distance this is, half of this, the one you calculated a minute ago, gives you the height. Okay, so you know the height here, and you got to solve for this one. So you have to do a little trig. Okay. Hopefully that helps on that one. This one's a little bit easier. 0.25 for your X. Number 1 is 0.25 for your X and 3 for your Z because you're starting out right here. 35 degrees, so you're basically going straight over here and you're doing the exact same thing you did over there. Tangent of A, because you know this. What do you know here? Okay, you know the height of it. There's 0.9. So you basically know the height of this is 0.45. So the Z would be 0.45, but you got to solve for this distance right here. Okay, and then you subtract that from 3 to get the number for Z. Okay, so you're trying to figure out this little distance right here using sine of 35 degrees and A over B. Okay, this one over here is a lot easier once you know all those numbers. So this is 60 degrees. So this one's easier than it looks. You can use trig to figure it out, but whenever you got a 60 degree angle, that just means there's a equilateral triangle in here because it's 60, 60, 60. Okay, since these are the same length. So that means this length across here is the same as that length. All right, and it tells you somewhere, let's see here, tells you the radius of this is 0.5. How the heck did I figure this out? Radius is 0.5. Oh, duh. Okay, sometimes I got thinking too hard here. I'm thinking the chord length. Okay, so the radius is 0.5. So this length from the center point is 0.5. So I know this is 0.5. I know this is 0.5. I know this distance across here is 0.5 because it's equilateral triangle. So it has to be. Okay, so you don't really even have to do any trig on this one. If you know the radius is 0.5, then this has to be 0.5 over. And they're giving you this. So the location number 4 is X would be 0.45 halfway up, and Z would be, you figured out, well, you can, I don't think you even, it gives it to you. So it's 3 minus 0.764, which is 2.36. Yeah, 2.36 minus half. So whatever the heck that is, 1.86 or whatever. So that would be this one. All right. So it'd be this minus that minus 0.5 gives you this one. So you don't even need any trig to figure out number 4, basically. All right. You do number 3 because you got to figure out this one to figure out number 3. All right, hopefully that helps out a little bit on that. It doesn't confuse you worse. So that's how you do homework number 7. Okay, let's get started on the CAD drawing now, which hopefully will be a little bit more interesting than that. Okay, so we're getting ready to start on the hammer. I don't have the video, but basically, you guys in class, you can see this is what we're going to make. Okay, we're going to start out by making the part without the thread. Okay, and today we're going to take it a little bit easier. We're just going to do the CAD drawing today, okay, and not machine it. All right, so if it says anything about machining on there, I'll probably postpone that somehow on there, because I want to come back from spring break and make sure that you remember everything we do, because when we machine this handle, it's very important that we don't mess it up, because it's a big part for those little machines we use. So I might change that date to put it off a little bit if the machining is included in there. All right. So there's a lot going on here. Today we're going to focus on drawing it. Okay. Once we draw it, we might run a few programs in here. Get some of the wax blocks machined. Okay, so circular interpolation, that was one of the other lessons. I kind of skipped over that, but to go through that real quick. So it's really not that hard. On circular interpolation, it's just like on a mill, except the G2 and G3 are switched. Remember, G2 used to be clockwise. Well, guess what? Now on the lathe, it's counterclockwise. Okay, just remember that. So if you're trying to go around a curve and you're going the opposite way of a clock, it's G2 on a lathe. A mill is the other way. And then if you're going the direction of a clock handle, it's G3. And remember, it's just from point A to point B. So if you start out here and you're going there, you just type in those two numbers, put the radius of it. Simple as that. Piece of cake. Wherever your start point is, you type in the X and Z and put the radius of the arc. And then you put G2 or G3. If it's going this way, it's counterclockwise, so that'd be a G2. Okay. Now there's another way that it's done, and a lot of the CAM programs use it. And the little trick about this is just like on the mill, if you go over 180 degrees, you can't use the radius method. You've got to use what's called IKJ method. Okay, and that's why I put this a lot more complicated. It's a lot harder. You don't really need it on a lathe, because very rarely are you going over 180 degrees. I mean, you'd cut the part off, because you remember you're doing the top half and the bottom half matches it. So it'd be extremely rare that you'd go over 180 degrees on a lathe anyway. So it almost always works on that. But on the mill it doesn't. But if you see this in your program where there's no radius in there, and there's I's and K's and J's, it's easier for like a computer programmer to write code that would automatically generate the G code when you use this method. And it's also what a lot of people learn for 50 years. Okay, so there's a lot of old timers around here still using that, even new people too. So you need to know how it works. So basically what it does is it does some subtraction off the center point. So instead of using radius, what you do is, and I just want you to know how it is. We don't actually use it in this class, because it gives you a lot more chances to make errors, because there's a lot more math involved. So it's the distance, the incremental distance from the arc start to the center. So if it starts from right here, you take the I would be in the X, so that'd be up and down, right? So it'd be 355 from the arc start to the center point, and that's 3.5. So this would be 0.0. That's a really little arc. So it'd be 0.05 or 0.005 would be the I number. Okay, but these don't necessarily match this, I don't think. And then it'd be the incremental distance on the K would be the incremental distance in the Z direction. So it'd be from the arc start to the center. So there's the start again. So it'd be from here to over to here. So it'd be that number minus this number from arc start to the center. Okay, and that's K. Okay. And if it's to the left or down, it's negative. Okay, so this is going left and it's also going down. Okay. All right, so hopefully I explained that enough. But we're basically going to use radius programming. Okay. So right here, put the number in you're going to, put your radius, boom, done. All right. And we'll get back into that after spring break. All right, so right now we're going to focus on drawing the hammer handle. Okay, in this assignment you will write a two-part program in machine. So we're basically going to, eventually we're going to draw the threads. Today we're just going to draw the handle, and when we get back we'll draw the threads, and we'll see how it goes today. We might draw the threads too. All right. And you guys will all build one of these, barring any catastrophic machine failures or anything like that. So it's kind of cool. So this is what would be a machinist hammer, basically. Okay, so it's got roughly a round end on one side and a flat end on the other. When I laid this out, it was just going to be way too complicated to make a carpenter's hammer, which I would have rather. But this is a machining class, so it fits pretty well anyway. But so you're going to basically machine all this out. And it actually looks really good when you get done, and it's usable. It is aluminum, so you if you hit heavy hardened stuff with it, you might dent the front end of it, but it does actually work too. Today we're going to focus on the handle, okay? And let's see here, 1 by 10 3/8. Center cut. So I cut them at 11. I cut them every 11 1/4 inches long, and I end up with 11 1/8 long. Okay, because the reason it's 11 1/8, I'm trying to remember all this stuff. So 10 1/2. I have to think about that one a little bit. But basically, we're going to draw up this handle. So what you do is when you're machining a part, again, is you take the customer's drawing. So like a designer would come up with something like this, like a hammer, and he'd say, okay, I want you to make these. All right, so you need to draw it from this again, right? Now, I always give you an example of what it should look like when you're done, but you shouldn't really be, and you can look at that while you're drawing to get some ideas, but don't necessarily draw it from that because there'll be rounding errors, because like this thing is, when you're going to draw this hammer, okay, just think about how you would draw this, and we're just drawing the top half of it again, right? So we're going to, in our machine, we actually have to mirror this because our machine will only do a lathe for like 4 or 5 inches or 7 inches. I think this thing's 10 1/2 inches long. We got to cut this taper. We got to cut all these loops in it, right? And it won't reach that whole way. Most lathes will, but we've got some pretty small lathes. So we're going to basically machine half of it, flip it over, and do the other half. Okay. Now I'm starting to remember this. So the reason it's 10.5 long when we're done, and the reason we're using an 11 1/8 piece is because the lathe has to hang on to something. It's going to hang on to this 1-inch piece. And on this side, it has to hang on to something too. And you can kind of see this handle basically screws into the head of the hammer. Okay, and it's small, it's shrunk down, so somehow that's got to be machined as well. And the way we do that is we have a chunk of metal on the outside of here that we cut off later. Okay, so that's going to be so it's 10 1/2 minus 5/8. So 5/8 of it sticks inside the or looks like I've got 0.75 on both sides sticking in there. All right, so we'll basically draw it from this. Okay, I'd have to change that. That maybe should be 1/8 longer there. So the way you draw this thing is basically you just draw. We're going to have to stretch our template, and then we'll do some offsets, and we'll start drawing circles with the radius. Okay, and copy them over here, and then we'll trim them off. All right, and then we'll do some more offsets. But you draw it basically from this. You wouldn't draw it like when you dimension it. It'll be all a bunch of ordinate dimensioning, which has rounding in it. So you can't draw it from the dimension one, or you'll have a big mess. Okay. So this is what it should look like when we're done. There's a lot here. Okay, this has all the And I'll basically draw it in red. Or it's yellow so you can basically see it on the screen when I'm drawing it in AutoCAD. Yours will probably be red. I usually have yellow so you can see it on the screen in front of the class. So this is all the threading. No, that's the next one. Evidently I don't have the threading in here. Good. That's the next program. Okay, so we're actually going to thread this too on the end, but that'll be the next slab. This slab we're basically just going to recreate this. Do not draw it with these ordinate dimensions. You know, that's the whole wrong idea if you do that, because draw it with it like we're going to do here in class. And notice it's dimensioned, the top half is dimensioned on one side because we can only machine half of this. The bottom half is dimensioned on the same side, but it's mirrored. Okay, so we're going to draw the top half first, then we're going to mirror it, then we're going to dimension it. Okay, so we're going to have to basically reach our hand in there, shut the machine down with an M0 code, reach in there, flip the hammer over, turn the machine back on, and then it'll finish running it. So it's not as bad as it sounds, but there's a lot going on here. So first thing we need to do is draw that hammer handle. I did make it 10 1/4 long, looks like. Good. Okay, so let's do this together. So open up AutoCAD if you haven't already, and we're going to focus on this handle. This is the only thing we're going to draw, okay? I got my head back into it a little bit. It's been a year, so. And you want to open up your lathe template if you haven't already. All right, so okay. So I'm gonna change mine to yellow so you guys can see it a little better. Okay, your dimensions should probably be red, but it doesn't show up on the overhead very good. I should have left red for the PDF, but anyway, you can zoom in to see them. So notice it's 375, and I mentioned briefly that this hammer handles 1 inch diameter. Okay, so we're going to have to stretch a lot of stuff to make it right here. Okay, but now this is the one I gave you for my template for the class, so I'm going to basically get rid of those. So let's save it right off the bat so we don't end up the same thing. So save as, and we'll call this hammer handle. Okay. Probably all caps again. Got to turn my caps lock on. Save. So, all right, so let's draw this thing up. So you should have a template just like this one. We need to stretch it first of all and make it 1/2 inch. So there's a million ways to do this. Definitely the easiest way is to stretch it. So whenever you stretch something, you have to use a crossing window in AutoCAD. Okay, so that just means going from right to left. Okay, so S is a shortcut for stretch. Just type S, enter. And then everything's got to be completely encompassed that you want to stretch. But you don't want to pick, if you encompass like this whole rectangle, it'll just move the whole rectangle. So I only want to stretch this top line, basically. Okay, so I'm only going to encompass that, and I'm not even going to worry about this dimension. I could grab it too, but I don't really need to because it'll be, I'm more worried about where the dimension starts. Okay, so I pick up here at the right, okay, and I go down and I just encompass that top part. Make sure you get just that top part like that, okay? You don't want to get like this, because if you get all that, now you're just going to move all that stuff. That's the stretch. You just want to hit the part you want with the crossing window, so from right to left. So I picked it, let go, and I'm going to pick another spot, all right, with my left mouse button. Okay. After you get everything picked like that, you got to hit enter to get it started. All right. Then you turn your ortho on. Make sure your ortho's on. Okay. Which you might not be able to see that in video, but make sure your ortho's turned on. I've also got my snaps on right now. I might turn them off later. Just grab a point out here in space. You can grab a point here, but then it might snap back to it when you grab it later. So I always grab a point out in space, okay? And then notice it's moving up. And you want to make sure you just move your mouse straight up. I'm not dragging, I'm just moving my mouse, okay? And then 0.125, because we want it to be half, and it was 375. Okay, now it's ½ inch tall, which is going to be a total of 1 inch when we get done. And I don't care if the dimensions got a zigzag in it. Okay, now we need this. Our part is 3 inches long. We're going for 11 1/4, right? I'm double check all this to make sure I don't mess up the video here. 11 1/4, yes. Okay, so our hammer says it's 10 1/2 long, but remember I said there's 3/4 of an inch over here stuck in the lathe, okay? That's going to get cut off. All right, so now we got to stretch, I'm going to stretch my whole border and everything. Okay, so that's for stretch again, okay? And I'm going to pick up here in the right and let go, and then go down here. And I'm just going to grab the right-hand side of everything, okay? Pick another spot, and then just hit enter after everything's picked, and then just pick a point in outer space. And you can, since it's such a big distance, you can grab here, but just a good habit to get into to go from there. Now it was 3, and I want it to be 11 1/4. So if I can do my math right this morning, if I mess it up, somebody yell at me. So it is 11 1/4 minus 3 is 8 1/4, right? It is pretty early in the morning. So I pick a spot, move my mouse the right direction, type 8.25, okay? Now if I did everything right, that should say 11 1/4. Yes, it does, yay. All right, so that's our layout. Now, we're going to end up making 2 of these because we got to flip the part. And that you do have to do that a lot. With, like this is we use small lathes here, but in the real world they're bigger. But they still have, if they're too long, they still have to flip that part. So it's very realistic to have to draw 2 halves of the item. So we're going to draw it like the hammer handle, just because it's easier to look off this and draw it the same and not draw a mirrored image of it. Okay, so we're going to draw the top one first, okay, and then we're going to mirror it and put the bottom one in. So now we need to stretch this bottom half of our thing down so we can fit both these in here. Okay, so now we're doing the same thing again. As for stretch, you can grab the bottom half of your border with your name and stuff, and don't touch anything else. Okay, like that. I'm really zoomed in there. Always zoom from where you're at. I'm trying to get it so you can see a little better. So basically, I'm just going that. I'm trying not to touch my dimensions because it'll drag them with me, and I don't want to drag them. Okay. If you grab your dimensions, it's not that big a deal. You can fix it with grips. So say you actually have to hit that, that's fine. Or you can just move your text later too. The main thing is move your border. That's all that really matters. Okay. And I'm just going to drag it pretty far down there. It really doesn't matter how big it is. Perfect. Okay. All right. Now I've got a nice big border to work with. Okay. Now I'm basically going to focus on drawing this part here. Start recording this. All right. So 3/4 inch this way. Okay, that's what we're going to hang on to. That's an easy one. Now put that line right there. Now remember, we're just drawing the top half of this thing. Now these parts here are a little tricky. They're not too bad. What we do is we draw a circle, and it's got to be 0.866 above this point here and 125 over. So we're going to draw a circle on this corner and move it. Okay, and then we can copy it 1 inch over, 1 inch over, 1 inch over. Okay, and then we'll just do some trimming. All right, and then we'll do a little offset over here to find the right height of this one, and we'll draw a diagonal line to it. So that's the long range plan. So make sure you do it that way. Okay, if you have a better way, that's fine, but you need to tell me which way you did it, because I don't want a broken machine over there. It definitely has happened. Okay, so let's do it together. So first thing we're going to do is offset this one over 3/4 of an inch. So over offset 0.75. Enter, and then pick the object, pick side. Okay. All right, so we just offset that over 3/4. Now the next thing we need to do is produce those circles, and they have a radius of 1 inch. Okay, so nice and easy. So pick circle. All right, and it is a radius because it's an arc. So we're draw a circle right on the very far corner of our hammer handle. Okay, far right. Just draw it right there, and it's 1 inch radius, so just type in 1, enter. Okay, and what layer am I on? Object, that's fine. Everything else is white. I'm going to switch to the 0 layer, at least for the part. Just to be consistent. All right, so now we need to move. And it looks awful big, but it's what it is, 1 inch circle. So we drew it right here in this corner, and now we need to move it to the correct spot. So M for move, enter, pick your circle, enter, okay, and now pick a spot, or pick the center of that circle, okay? And it really wouldn't matter where you pick as long as you go the right distance. So then you got to type at, okay? And we're going negative 1.25 in the x, negative 1.25, comma, and we're going up 0.866. 0.866. So negative 1.25, comma, 0.866. Okay. Now we did it right. It should basically cross right there. Okay. Real close anyway. All right. And now we're just going to copy that thing over. So now make sure your ortho is on, which it should still be. We're going to copy it over 3 more times. So CP for copy. Pick our circle, enter. Pick our center point and start moving to the right. And just hit 1, enter, 2, enter, 3, enter. Because they're all moving over 1 inch. All right. 1, 2, 3. And then just hit enter to finish it. And hopefully yours looks like that. Okay, let's trim those circles out of the way. So we want to use the slow method for trim. So I think I've got 2021 on here, so it's a little bit different. They changed the trim program a little bit. But TR for trim, shortcut for trim is TR, enter. Now you want to pick the object you want to trim with, okay? So that'll be this line. Now I've got to go down here and pick cutting edges in 2021 and then pick it, but you just got to pick the object and then hit enter, and now pick the ones you want gone or window them, and they're all gone. Okay, now leave that line across here because we're going to use that to basically do our 40,000th offset here in a little bit. Okay, so don't trim that out yet. We'll need those in a little bit because we're basically going to we're going to have to use them for those blue lines going across here, okay? That's the part that gets cut. Going to have to get cut out, so that'll help us in a little bit. All right, so I'm going to do a little bit more of this. Let's see here. So 6, 6, and then 3/4. Okay, I'm trying to remember all this. All right, so basically it's 6, 6 tall here, right? That's where the edge of it is at, right here, okay? So half of that would be 3, 3. So we need to offset our green line up half of this, which is 3, 3. So O for offset, 0.33 for our distance, and your center line offset up, okay? And now we need a line basically 3/4 this way. Now I don't think I have one in my template, so I'm going to draw a line right there and then just move it over. I'll draw a line from here to here, okay, and then I'll move it over 3/4. M for move. Oops. M for move. Pick the line I just drew. It should be on top, so it should grab it. I got to retell it that. Enter. Pick a spot, and I do have ortho on, so 0.75 over. Okay. 3/4. 3/4 over, okay, because there's going to be 3/4 left on this that we have to cut off later, okay. Now I want a diagonal line between those two, okay, so line, and that's the most of it right there, right there, okay. So I did diagonal line. Now I'm going to check this and make sure I didn't screw anything up. 0.33, I think that's right. All right, so we have the top half of this drawn. You can get rid of this construction line there if you want to, that top green one or whatever, and delete it. I don't think we need that anymore. After I delete stuff, and then I have to put it back. All right, so what we need to do now is generate our machining, okay? And whenever we're doing something with a lathe, remember we have some clearance areas because these are cut again on a bandsaw most time for lathe. And it can be, it could be a guy doing that at night at 1 o'clock or a high school kid. It's a pretty easy job, but then they don't do it very accurate because they're thinking about going partying with their buddies and not necessarily, not that you guys would ever do that, not actually cutting these right length. So they need to be a little bit extra on the side, right? So remember we're going to go 0.1 over here. So offset the far right side of your hammer handle 0.1 over, just so we got a safety area like we did last time. So over offset, 0.1 is the distance. And I say all that stuff because that's what I would have done if I was when I was in high school. And then we go up. We don't go near as much up because you buy this rod that we're going to make the hammer handle from a company, and it's usually extremely accurate. Okay, on the diameter. Okay, so the diameter usually is, I mean, it's right on within 1/1000th of an inch. So we don't need to have as much clearance. You just need to have enough for the machinery and stuff to be safe. So I usually go like 0.01 up. So enter to finish offset, enter to repeat it, and 0.01, 0.01. Okay, just 10,000ths. And pick the object, pick the side. So it's just barely above it. Okay. Okay, so those will be our safety places. Whenever we're moving from one spot to the next spot in high speed, we need to be either over this or up there, unless we already cleaned it out, of course. But those are our safety spots: 0.01 up, 0.01 over. Okay. And then I'm going to start using some of the colors. Now you can basically use this one to kind of get some ideas how we're going to do it. So these are all going to take off 40,000 like we did before, okay? And now there's not any material up here, so we go 40,000 off the part, not off that safety line, because there's really nothing there. It's just a safety position, okay? But you can see some of the leftovers are of it. And we're also going to use that 0.01 to basically do our rough cuts and finish cuts. Let me get my head into this. I don't want to make any mistakes here. Try not to. All right, so we need to put those fillets in there too. I almost forgot them. So if you look at the hammer, all right, it's sharp edge right here just because it looks cooler, I thought, and sharp edge right here. So in every design stuff, if you ever want to actually make something to sell, you need to design it like what would sell. You know, the iPhone sells because it looks good half the time, not necessarily because it works good. But you always want to design stuff so it looks good and also try to make it work good. But I made it sharp on this edge, and I wanted it also not to cut my hand when I use it here, so I've got a radius on these middle ones. And the radius of there is 0.182, okay? Where I came up with 0.182 that day, I have no idea, but usually I try to use real numbers like 3/16 or an eighth, but that day I didn't. So we did our offsets, enter, escape, finish that, and after fillet, and radius is 0.182, and then fillet these middle ones together. Seems like a lot. It's a lot sharper in Inventor than it does right here. Well, somehow I had a 1/2 inch radius. I don't know how I ended up with that. It must have been from an old something I did before. I'm going to have to undo mine. F for fillet, R for radius, 0.182. I think I didn't type in, I just went straight into it. So I had to type R for radius. Sorry about that. And then pick the objects you want to fillet. Should look like mine. I'm hitting enter between the two. Okay, to repeat the command and fillet them. All right, so we're just doing the middle, not the ends. All right, just the middle. Okay, so we've got that done. Now we've basically got to get our offset location, okay? So remember, the next thing we need to do is we need to offset away from this part. We remember when we did that simple practice part last time, you don't want to machine right to the part because you want to make the finished part nice and shiny, so you got to slow down the feed rate. So in spinning the same RPM, it actually does a nicer, cleaner cut. Okay, because you don't care if it looks clean when you're just roughing and getting rid of all the metal in there, right? So we've got to offset this 10,000ths above so we stay away from it. So let's join all these little parts here, okay? So J for join, all right? And the easiest way to pick them is just start on the right and move to the left and try to window them all without windowing the parts above them, which is a little picky. See how I'm trying not to get into that part? I don't want that top line, I just want these little ones. Okay, so I just want those. Don't get anything else. Then hit enter, and it should join them all together. Okay, which is what it makes it a lot easier to offset, right? 'Cause if you didn't join them together, it would actually leave a bunch of little corners on those radiuses and stuff in your billet. You kind of need to join them together. Okay, now we're going to do O for offset, and it's still on 0.01 on mine, so I'm just going to hit enter and pick the object and move it towards the top. Make sure you move it up and not down. It's got to be up. Okay, We want to be away from the part. We don't want to be into the part. Okay, so now I think we've got, oh, we need to do it over here as well. This one needs to be, so I'm going to pick that out. I can pick up on it. This doesn't matter. It's getting cut off, so I'm not going to offset that one. All right, I'm just going to cut that thing off anyway. I think that's it. Double check here. I shut that down, so I don't have to keep picking it. So Control plus and Control minus zoom in and zoom out. So that's kind of how I'm doing that all the time when I'm zooming in and out in a PDF. All right, it's hard to see, but I think I've got everything in here. Okay, now we're ready to do the 40 thousandths down. Okay, I can trim that up. Okay, so I usually make that a different color because it just is too much of the same color otherwise. So like, so the second from the top line, remember the top one's 10 thousandths above. Pick that and just maybe switch the colors on it. So I'm going to go over here to properties if I can find it. It's by layer, and I'm going to make it something like cyan or something. That's what I did last time. If I could see decent. Okay. And then we're going to offset that down 40 thousandths repeatedly till it gets all the way to the base. Okay. Maybe there's one more over here than there is in the handle part of it or the grip part. So overall offset 0.04 for the distance. Just 40 thousandths. Pick the little blue line. This side, pick that blue line, this side. Keep doing that till you get all the way down. And there's even a little bit right here, I think. Well, no, that's right out 40 thousandths. I guess we don't need that one. I'm going to zoom in here because I'm not sure.
Mine says it's just a little bit on the bottom.
Yeah, and 2 thousandths I'm really not worried about. So we got 3/8. Yeah, we should 3, 4. Yeah, it should be good. So I got 1, 2, 3, 4 total lines there. 1, 2, 3, 4. Yep. So we don't need that bottom one. Make sure on the loop. So that one is touching down here. I'm deleting it off. Okay, so that'll be all the lines. You have total of 4 blue lines if you include the top one. All right, now we've got to trim this out to match this. So you need to basically trim it out so it only touches the safety line, which is 10 thousandths above. So we're going to use a cutting surface trim again, which you don't necessarily use a lot. So it's, even though it's the first one picked on AutoCAD. So TR for trim, okay. And again, you don't have to pick cutting edges on all the old AutoCAD, but 2021 they're making you do that. So I got to pick cutting edges. You just start picking lines. So I want to pick this one. I want to pick this one. I want to pick the top of my loop here. There. And there. Okay. So I'm picking all the parts where I'm trying to basically make it look like this one when I get done. Okay. Which is basically just going to cut off the remaining of the metal. Right. So once I pick all them, then I hit enter. I got to get back on AutoCAD, and then I hit enter. And now I want to pick the parts I want gone, which I guess I didn't need to pick this one. So I'm double doing it here. And that one I'm leaving in there. Okay. And then I need to do it again. I did one extra line there, but oh well. Do need to pick it in here. Okay. So it's a good thing I picked that actually. Okay, so now I'm getting rid of all the ones in the middle here. So it should look just like the mine, where you basically only have it on that top. If it doesn't, you're not doing it right. So, because we don't want to extend it past, as it won't be the right dimensions. Make sure I got all this right, I think. Okay, I think that little one stays there, don't I? What do I do there? I don't remember. I have to look at this. Okay, so I had trimmed off this top one on that case too. So I'm basically trimming off this very top white line too. Okay, so don't forget that one. Doesn't really hurt anything. It's just more stuff in there you don't want to look at. So I'm getting rid of that one as well. The top. had to tell it in AutoCAD that I wanted. So I basically got rid of that top one across there. I think that's it. Oh, and here too. Get rid of all these. I'm leaving this one on the top. Okay, when you get done, it should look like mine and also like this example here if I didn't mess anything up. All right, and I think now we're ready to do ordinate dimensioning, and if you did everything right. So there's a couple little things on here, like I wrote saw cut on this, okay? So make sure when you double click on it later after you do the dimensioning and write saw cut. Okay, so that's that one. Now, before we start dimensioning, we're going to bring it down. We're going to make the mirror image of this thing, okay? I'm going to show you how to do that, and then I'm going to basically leave you on your own to finish this project up, and we'll run some parts today. Is the plan. Okay, so let's finish this thing up together, or at least get to a good point. I'll tell you. Make sure you use ordinate dimensioning to dimension all this, okay? And it should be dimensioned exactly the same. If it doesn't, you've got a problem. So ask for some help. All right, so I'm going to copy this part straight down, basically. So CP. Okay, window it all. Looks like I'm getting my top of my border there. I don't want to get top of my border. Very carefully getting everything except the top of the border. Okay, I do have my ortho on. Enter. Pick an object somewhere or place somewhere and just bring it down so you got plenty of room for your dimensioning down here. Okay, put it down there and hit enter to finish it. Okay, so now I got two of them. Now you need to mirror this thing. And it's nice to mirror it about a midpoint. The only midpoint I got on mine looks like probably don't have any that are a good line, that are really a true midpoint. This green one's going too long, so I'm going to fix this. So actually, I'm going to trim that green one off. Trim. Okay, and then I'm going to extend this thing over there so I got a midpoint. You don't necessarily have to do this part, but I want to mirror across a nice midpoint. So now I got a nice midpoint line. Okay, I can mirror across what I got going on over here. Looks like that thing goes too far too, so I'm going to use grips and fix that. Okay. Okay, so I'll walk around and help anybody that's having a lot of trouble here in a minute. So now once we get this copied down here, we're ready to mirror it. So MI for mirror, okay, enter. And from right to left, pick everything you need. Open your window, enter. And now you should have your snaps on, so you should be able to grab the midpoint of that. Because that should be turned on by default. It looks like it's not going to land on it, but that's all right. So now I'm going to basically pick the midpoint. I'm going to go straight down, pick a spot and space it straight down. Okay, and this is very important right here. You hit yes, default's no. So I picked yes at the bottom. I don't know if you can see it or not. Make sure you pick yes. Now I get rid of the originals. And now I'm going to hit M for move and P for previous. That lets you pick previous objects. Okay, and hit enter. Enter again to finish it out. And pick a point space and move it back into my border so I can see everything. Okay, now there's a couple other little things we're going to do here. So these, this becomes, the axis actually moves over to here, right, on the next one. And these dimensions are going to be in the wrong spot. So I'm going to basically, 0 and 5 is fine, but it's not 11.25 over here. It'd be 0 if you zoom in there real close on the bottom one. Still can't see it, but it's 0, okay? So we need to make it more like this for the bottom one, right? So basically what you're going to have to do is delete that ordinate off there, okay? Same thing over here, delete these ordinates off, or you just move all this over, don't delete those. And that one says 0, 2. So M for move. Or grab all this stuff, because it's not going to be dimensioned over here, because you can't reach it that far anyway. The mill only goes 7 inches or the lathe. So I did M for move, and make sure you get right in the middle of that part reference 0 pointer. It's called a PRF, part reference 0. That will be on the test. Pick that point there, and put it where it's supposed to be, which is, now remember we got 100,000 over extra here, so don't go all the way to the edge of it. We just want to go to right here. We need to delete that extra off. Right. There. And actually on this lathe, I don't know if we needed that 100 thousandths extra. Probably not. No, we didn't need it on this lathe because the lathe's not going to reach that far anyway. Okay, so we want to delete that 100 thousandths extra off on both sides. So I'm deleting that one. And I'm going to top them and delete it as well. So we didn't need that 100 thousandths extra. Sorry about that. Usually you do, but the lathe don't reach that far anyway. It only goes about right here, 7 inches over. It won't even go that far anyway, so you can't run into that end. All right, probably you can leave these like this, the axis. When you dimension these, remember how you got to move the UCS. So I'm going to do 1 or 2 dimensions on each part, and then I'm going to stop the video, and you have to do all the rest of them and make it look like this, okay? So watch me for 2 seconds. So I'm going to basically go to annotate, right, like we did before, drop it down, get my ordinate out here, and I'll dimension this whole top until I'm all the way done. I'm just going to do 1. Make sure you're on the dimension layer, not on the part layer like I am. And then once you get all this top done, then you move the UCS to the bottom. So just remember how to do that. UCS, enter. And you got to use the old method. If you just drag it and move it around, the ordinates won't work. It's a little bug in AutoCAD. So you got to type in UCS and pick a spot for it. And then once you pick a spot, you don't want to rotate it. Pick a spot and hit enter. Okay. And now you can do all the ordinates down here as well. And they should match this one. If they don't, that's because I either did the video wrong or you did it wrong. One of the two. Okay. So, and then if I did the video wrong, you did it wrong too. So hopefully I didn't. All right. I think that's it. Make sure you put all the words in there. Don't leave out any of the text. When we get that done, show it to me. Make sure it's right. Make sure all your numbers matches perfectly. They got to be exactly right on. If they don't, something's wrong. You need to zoom in to see where everything's dimensioned because it's pretty tight where some of these numbers are at, right? So you can really zoom into where I have where to be. So this one would be on the bottom. Remember, the bottom numbers are on the part. The top numbers are always on the safety positions or the cutouts. Okay, so when you see these two, you're like, well, which one did he pick? Well, the bottom ones are on the actual part, remember? And the top ones are on the the part that's getting cut out. So anything across the top here. Now then in this case, 340, that is actually on the top right there. I probably should have put it over to the right, but so this 340 is up here, okay? 330 is on the part. And all these should be on the cutout part. Same thing when you get down here. All the ones on the outside should be on the part that's getting cut out. All the ones on the bottom should be on the part that you're keeping. Okay? Because the offset radius is in a different location. So these are actually on the intersection points of the arc to arc, okay, right here. And these are actually on the blue line. They're not on the intersection points. Okay, the edge of the blue line. They're the intersection points between the blue line and the arc, but not the arc and the arc. Hopefully that helps out there. That's on the top radius, of course, and this is on the bottom. This is a center point of something. I guess that arc. That's what showed up there. Probably a center point up here too, yep, that radius. Both the same. All right, if you have any questions, email me. Or bring them to class and I'll help you out. So Dave's Lab just finished that up. Okay, now of course don't move your UCS till you get the whole top dimension. I did it in the video to show you how to do it. But don't move the UCS till the whole top half is dimensioned. Otherwise your numbers will be all wrong, right? So move the UCS after you get the whole top done. Dimension this one all out, and then move your UCS down here and dimension this one all out. Okay, you can't do the dimension for the top and the UCS down here. Ordinate works off the UCS. Okay, one of the students noticed I missed something. So everybody look up here once, okay, please. So there's one part here where it needs to be filleted together to get this dimension, and the same thing at the bottom. All right, now his wasn't filleting very good, but so right here, these two should have been connected. All right, we probably should have joined this line, this white line to this one and then offset. We didn't. So we need to fillet those two together. So after fillet, I don't know if it's going to work. I'll show you 2 ways to do it because it didn't work on his. After fillet, R for radius, 0, okay? That's a way to basically extend 2 lines together. Okay, and that's what his did. It tried to do this crazy circle thing, which is just weird. But anyway, So it doesn't actually fill it together. So you gotta make some construction lines to extend them together. So helper line, okay, and I have to turn ortho off. I'm gonna draw a little line over here so I can extend to it, okay. And I'm gonna draw another one up here to extend that other one too, okay. I actually don't need that one. I can delete it. So I'm gonna extend this one to here first. So EX for extend, enter for the fast method, go there, and go there. Now trim it up. Sharp trim, enter, get rid of that one. So that's a pain in the butt way to extend it, but that's the one way I found to do it. All right, now that the dimension will be right. Okay, and you got to do the same thing on the bottom in this location. Okay, so if you haven't looked up here, make sure you look. These need to be touching. Okay, now I'll give you that correct dimension at the corner. Okay. All right, so there's one other little area, guys. I noticed we had a problem. So up here, just like that needs to be extended there to get it to. I think if you dimension that over, it's probably going to come off a little bit off. So if I go to annotate, let's just try. I'm on computer. The ordinate dimension, I'm having a heck of a time getting it to pick. Not liking it. It did get it, I think. It just didn't show up. Okay, so that's my UCS is the wrong spot. Sorry, UCS. Enter. Annotate ordinate. Did pick. It's not moving quite right. So I've got 509 there, right? So this needs to be up at 510. So I'm going to do O for offset 0.01 because I deleted this line all the way through and it needs to be up there. Okay. And then these lines need to touch again. And of course they don't want to do that very easy. So I'm going to do a line across there like we did last time. Extend. And evidently that line wasn't long enough. Extend. There, and extend this one to that. And delete that. And trim it up. It usually should fill it to that, but since we joined it, I think it doesn't like it. All right, so now I should have a dimension there I can use. And it might be a little bit off from what it shows in there. So that'd be your 5.1 dimension, okay? Like right here. Now this 7.55, I don't know. I might have grabbed a little bit wrong on that one. Let's see here. So annotate ordinate 7.53. So it is a little bit different. So I must have, when I did this one, I probably had this extended to this one. It's all safety factor, so it really doesn't matter. I probably went from that one not that time. Oh, that's 7.50. I'm not sure. But either way, 7.53 is fine there. You won't get 7.55, okay?